Swayam Prabha. Digital India. Educated India.
Hello everyone. So this is the first lecture on Advanced Foundation Engineering. So this course I have developed for the UG as well as the PG students. So before you take this course, so for the UG students, you should already take the course on soil mechanics as well as the foundation engineering, because this is the advanced foundation engineering course. So you should have the knowledge of soil mechanics and some portion of the foundation engineering also. So here the things that I will cover in this course, that the introduction and the soil planning of soil exploration for different projects. So, and these soil explorations are boring and various penetration tests, geophysical soil explorations. Then I will discuss the shallow foundations and method of estimation of bearing capacities, different shallow foundation bearing capacity estimation theories, and then I will discuss foundation on sloping ground, then foundation under eccentric and inclined loading, and foundation on two-layer soil system. Then method of estimating the settlement of the foundation, shallow foundation or the footing and the raft that I will discuss. So in the next part I will discuss the concept of beams on elastic foundation. Then by using field and the laboratory test data, how we can determine the dimension and depth of foundation. Then I will discuss about the pile foundation, stress transfer or load transfer mechanism along the pile, then pile load test, then pile group capacity and settlement calculation, negative skin friction. Then I will discuss about the analytical estimation of load settlement behavior of piles, then lateral loaded piles, uplift capacity of the piles, and I will discuss the well foundation and different codal provision. And then foundation on probabilistic soil, mostly on collapsible and expansive soil, and foundation or anchors under uplift loads. So these are the content of the of this course. So these contents will not change, but this week wise distribution may slightly change during my lectures. So but the content will remain same. So the first module, the first part, that I will discuss the soil exploration, and before I discuss the soil exploration, so these are the list of reference materials or book that you can follow. So these books are the Principles of Foundation Engineering by B.M. Das, then Foundation Analysis and Design by Bowles, then the Pile Design and the Construction Practice by Woodward and Tomlinson, and Pile Foundation Analysis and Design by Paulus and Davis, and Geotechnical Engineering Principles and Practice of Soil Mechanics and Foundation Engineering by B.N.S. Murthy, and Basic and Applied Soil Mechanics by Ranjan and Rao. So these are the references you can follow for this course. In addition to these books, I will also follow few journal papers. So those references I will give directly during my lectures. So first part that I will start is the soil exploration, because for the foundation design we should know the properties of the soil. So these soil properties can be determined either by field test or by laboratory test. So that for that purpose we have to do the soil exploration. So the definition of the soil exploration, that the field and laboratory investigations required to obtain the necessary data for the soil and the proper design and successful construction of any structure at a site is collectively called the soil exploration. But in this part I will discuss mainly the field investigations. The choice of foundation, its depth, then the bearing capacity, settlement analysis, all depends on the properties of the soil. So, that is why the soil exploration is very important, and the objective of the soil exploration is to determine the nature of deposits of soil, depth and thickness of various layers, then location of groundwater table, which is also very important, then the obtaining of rock or soil sample from the site, and then we will take those soil samples into the laboratory and we will determine the engineering properties of those soils and the rock strata for our construction purpose. Then we also determine the in situ soil properties by performing field tests. So, in this part I will discuss these different field tests. So, these are the different soil exploration techniques by which we can determine the soil properties. So, few of them are directly, few of them are used to directly determine the soil properties, and few of them are used to indirectly determine the soil properties. For example, we will determine or measure in the field something else, then we will correlate those properties with our required design properties or the strength properties, so that we can determine the bearing capacity or settlement of the foundation. So, these methods are test pits, boring, then the penetration test like standard penetration test SPT or cone penetration test CPT. Constant penetration test is two types, one is static cone penetration test, SCPT dynamic cone penetration test, DCPT, then pressure meter test, dilatometer test, vane shear test, and different geophysical exploration like seismic reflection survey, seismic refraction survey, seismic crosshole survey and resistivity survey. So, by these techniques we can get the soil properties, and then we use those soil properties to calculate the load carrying capacity or bearing capacity or settlement of the shallow or deep foundation. But we can do the plate load test also, where directly we will get the bearing capacity and the settlement of the foundation, shallow foundation, and we can do the pile load test, where also we will get the directly the pile load carrying capacity and the settlement. So, these two tests also will be discussed, but not in soil exploration part, it will be discussed during the shallow foundation and the pile foundation part. So, one by one I will discuss all this technique in brief. So, these are the different techniques that I have used. The first one is the SPT, then the VST means the vane shear test, then PMT means the pressure meter test, then CPT means the cone penetration test, and DMT means the dilatometer test. So, out of these tests you can see first three, that means SPT, VST and PMT, we need the borehole. That means you have to construct a hole within the soil, and then we will place the instrument within the hole at the required depth to get the soil properties. Or here basically, as I mentioned, that few of the tests are indirect. So, these are basically the indirect test. So, by which we will determine something else, then those things we will correlate with our required soil properties. But for the SPT and DMT, we do not need the boreholes, we will push these instrument into the soil, and then we will get the soil properties, or the we will measure the properties which is required to determine the soil properties at different depth. Some reading will get the continuous, some will get some interval. So, now first one is the test pit, which is a test pit. You can see this picture, which is the test pit. So, generally the depth of the test pit should be the depth of the foundation, and then these from this pit we can collect the soil sample. So, this is the direct method by which directly we can collect the soil sample, and then we can take those soil sample into the lab, and then we get the soil properties. But these test pit method is suitable for small structure and for very shallow depth. Okay. So, that means this soil can be inspected in their natural condition, and we can, as I mentioned, collect the soil sample from the base of the peat or the base of the foundation itself. Now, this method is suitable for up to a small depth of 3 meter. As the depth increases, the cost increases rapidly. Okay, so, for the greater depth, you have to provide the lateral support for the soil. Then these pits are generally used for supplementing the other methods or for minor structures. For next one is the boring. So, this is the making of or the drilling borehole into the ground with a view of obtaining soil or rock sample from specific or known depths. That means, the boring is basically done to collect the soil sample from a particular depth, which can be a specific or known depth. So, there are different common boring methods available are auger boring, wash boring, rotary drilling and pick version drilling. So, the auger boring this is useful to advancing the borehole into the soil. Auger may be the hand operated auger or power driven auger, but the hand operated auger is used relatively for small depth up to 3 to 5 meter, and then the power driven auger we can use for the greater depth, we can use it for up to 60 to 70 meter in case of continuous flight augers. So, auger boring is convenient in case of partially saturated sand, silts and medium to steep cohesive soil. So, these are the different augers. You can see these are the different augers. This is a helical auger and these are the rods. So, these rods are attached with the augers to increase the length and so that we can place these auger at any required depth by attaching these rods. So, you can see these photographs where these samples are collected in the auger. So, the soil auger is advanced by rotating it within the soil and you also push it. That means, you have to push it and at the same time you have to rotate it, so that it will insert into the soil as well as the same time the soil will enter into the auger. So, when the auger is filled with soil, then you have to remove it from the soil and then we collect those soil sample. So, and definitely the way we are collecting the soil sample, the soil those we are collecting are very disturbed sample. And then you have some YouTube video link is also given. So, you can see this link and you can see these videos also. Anyhow, you can see these videos also, these links are given. And then we can go for the sail and auger boring. So, these are used widely in India. So, sail, which is a heavy duty pipe, you can see this sail is a very heavy duty pipe. So, these and with a cutting edge and here is a one way valve is attached. So, these sails are raised and let fall into the hole. So, that means, in a bore hole these sails are allowed to fall from a certain height and then soil is cut, because as the cutting edge is there and these soil is enter into the shells and there is a one way valves. So, it will allow the soil to enter into the shell, but it will not allow the soil to come out from the shell when it is removed from the soil. And then this way we can, when the shell is filled with soil, then we can remove it and then we collect the soil samples. And this cells is used when the auger boring is very difficult. So, otherwise we can go for the auger, where the auger boring is difficult, then you will go for the shell. Then next one is the wash boring. Wash boring is commonly used for collecting the soil sample below the water table, where the auger boring is not suitable. So, that means, where we want to collect the soil sample below the water table, then we have to go for the wash boring. So, this method is very used for all kind of soil except those mixed with gravel and boulders. So, if the soil is mixed with gravel and boulders, then this method is not suitable. So, that means, there is a casing pipe is pushed and driven into the soil by a drop hammer. this is the casing pipe which is pushed into the soil by a drop hammer, and soil particles collected represent a very disturbed sample and is not very useful for the strength properties or the permeability properties calculation determination purpose. So, later on I will discuss that where we will use the disturbed sample, where we can use the undisturbed sample. So, suppose for the strength properties, or for example cohesion and the friction or the permeability or the consolidation properties, we need the undisturbed sample. That means soil in its natural condition, but the way we are collecting the soil sample by wash boring is a totally disturbed sample. So, we cannot use this disturbed sample for this test for this purpose, but we can still use this sample for other purposes also. Those I will discuss in the later on. So, the wash boring is primarily used for advancing the boreholes. So, but whenever this sample is required, then this chopping bit, so this chopping bit is replaced and then a sampler is attached in this chopping bit. So, the change in the rate of progress and change in color of wash water indicate the changes in soil strata. So, now I will discuss again the steps by which we can perform this boring technique, that the casing pipe is pushed into the pushed and driven into the soil by drop weight. Then hollow drill bit is screwed to a hollow drill rod. So, this is the bit which is screwed to a hollow drill rod inside the casing. First the casing is inserted into the soil, then this bit is screwed with this rod, and this height of this rod can be increased by attaching another rod or number of rods. So, and then this rod is connected to a rope passing over a pulley and supported by a tripod. So, this is the tripod, and then water jet is applied through the rod and the bit into the hole to loosen the soil sample. Then the soil water suspension forced to upward direction. So, that means when we apply the water jet, the soil becomes loose. So, this soil with the water, this slurry is forced to, that means here we apply the jet, in this arrow we can see in the downward direction we apply the jet, and it is forced to move this water jet, water and the soil particles, this slurry in the upward direction. So, then it will go in the upward direction through this casing pipe and it is collected to a place. So, that means this place, this is called a settling tank. When this suspension force upward and this it is collected in the settling tank where soil particles settle and the water overflow into the sump. That means, we allow this slurry to settle, the soil particles settle and the water is overflow, and then we collect the soil sample. Definitely, as I mentioned, the way it is collected is a highly disturbed soil sample. And again, these are the YouTube link are given. So, you can use this link and you will get that video. Then the rotary drilling. So, this is the drill bit. So, this is the bit which is fixed lower end to the drill rod. So, this is the drill rod where this bit is fixed at the lower end and it is rotated by power while being kept in firm contact with the hole. That means, we will firm contact with the soil, this bit which is attached with this drill rod is rotated, and so that means this rotated and the bentonite slurry is forced under pressure to this drill rod and it comes bringing the cutting to the surface. That means when we rotate this bit along with the drill rod, at the same time a bentonite slurry is applied through this drill rod. Now, this bentonite slurry, what it will do? It will mix with that the cutting pieces and then again it is forced to come in upward direction. That means, again this is this arrow direction, arrow you can see this is a bentonite slurry is applied and here the cutting bead which is rotating with the soil or rock, then the pieces which is generated, then these mix with the bentonite slurry, and it is then forced to move in the upward direction, and then it is forced to move in the upward direction, then again it is collected in a settling pit. So, then when soils, again this way we can make the boring or boreholes, and then when we can want to collect the soil sample, then these beads are removed and sampler is attached and we can collect the soil sample. So, we can collect the soil sample as well as you can advance the borehole also. So, these can be used in sand, clay and rocks. So, this is very fast method. Even rock cores may be obtained by using suitable diamond drill beads. So, using suitable beads also we can collect the not only the soil, but also we can collect the rocks also, but it is a very fast method. Then the precursion drilling, here is a heavy drill bit is attached with a drill rod and the cable and is driven by a repeated blow. So, previous one is this beat is rotated by power, but here it is inserted into the soil by driven by a blows. Okay. So, then again the water is added to facilitate the breaking of steep soil of the rock, and then the slurry of this material is bail out in intervals. That means, here when this water is added and this slurry is bail out in interval, and this boring is advances, and then the boring is advanced, and then the method cannot be used for loose sand, and it is slow in plastic clay and formation gets badly disturbed by impact, because here we are applying the impact, because here applying the driven by blows. So, that means we are applying repeated blows or the impact. So, that means the formation may get badly disturbed by this impact. So, now we will go for the next part, which is the penetration test. So, first one that I will discuss is the standard penetration test. So, this is a very popular test. So, here we use a split spoon sampler. That sampler is attached to a rod, and this rod I can extend by using number of rods, and we can get put the sampler at the any depth as we require, and then we apply the hammer blow on this rod, and those, so that the sampler or this split spoon sampler tube is driven into the soil by a distance of 450 millimeter in 3 intervals, that means 150 millimeter each. So, and we measure the number of blows required for each 150 millimeter penetration of this sampler into the ground. So, here we apply a hammer of 63.5 kg weight with a free fall of 750 millimeter. So, this hammer weight is 63.5 kg with a free fall of 750 millimeter. And then as I mentioned that we are measuring the number of blows required for each 150 millimeter penetration. So, the summation of last 300 millimeter penetration n value is the SPT value. That means, we will neglect the initial 150 millimeter penetration required blows for the sitting load purpose, because that will be treated as a sitting load. So, that there should be a proper contact between the soil and the sampler tube, and then the number of blows required for last 300 millimeter penetration or 30 centimeter penetration is the n value. So, this is the 63.5 kg hammer, which is applied blows for 150 millimeter penetration, and each time we measure the number of blows, that is N1, N2, N3, as I mentioned, that N1 will not consider. So, the SPT value will be summation of N2 and N3. So, this is the SPT is N2 plus N3. So, summation of N2 and N3. So, it will be SPT value. So, this test can be conducted 1 meter interval, but not more than 1.5 meter interval. So, that means here advantage is that we will get the n value. So, that n value later on we will use for to determine the soil properties. As I mentioned, those few tests are directly we can get the soil sample. So, boring and the test pit we can collect the soil sample directly, but here in penetration test SPT we are getting the n value, but advantage is that here also we can collect the soil sample, which is not true for the another type of penetration test, that is cone penetration test, where we will get we will not get the soil sample directly from the field. So, but in the SPT we will get n value as well as the soil sample. So, that when you will realize that we have to finish our test. So, one is that then we will fix that up to which depth we will do the test. So, that is one option. Another option that every time you have to go for 450 millimeter penetration, but sometimes because of the there is a very hard strata that we cannot go for 450 millimeter penetration, then when we will stop that test in such case. So, for that purpose we have to satisfy few conditions. So, those conditions are that if there is a 50 blows are required for any 150 millimeter increment, then we will stop there, okay? Or 100 blows are required for any 300 millimeter penetration, then also we will stop there. Or if 10 successive blows if produce no advance, then also we will stop. That means, if any of these criteria or condition is occurred in the field, then we will stop the test. So, one is 50 blows for 150 millimeter penetration, 100 blows for 300 millimeter penetration, or no penetration for 10 successive blows. Okay. And then once you get this n value, so the collected soil sample will take into the lab and you do the test. But this n value is very important for us, because we will use this n value to determine the soil properties by using different correlations. So, now once we get this n value, then we have to apply different corrections. So, what are those corrections? So, as per IS code, we have to apply two corrections. One is the overburden pressure correction, granular soil you have to apply, and another is the dilatancy correction that you have to apply for saturated, fine sand and silts. Okay. So, because overburden pressure correction is required, because you can see that very shallow depth your overburden pressure or the pressure that the existing soil is given is very less, but at the greater depth this overburden pressure is very high. So, because of that in a shallow depth we will get a very less amount of n value, and in the greater depth because of this high overburden we will get the very higher amount of n value. So, we have to apply a correction so that we can remove this overburden effect. So, you can see the IS code recommends to use a chart. So, this chart you can see. So, this is the correction factor Cn, and here effective vertical overburden pressure. So, effective means it is effective, it is not a total. So, effective vertical overburden pressure in ton per meter square. So, you can see that if it is 10 ton, this effective overburden pressure, then no correction is required, because your correction factor is 1. And if the effective overburden pressure is less than 10 ton, then you can see the Cn value is greater than 1. And if the effective overburden pressure is more than 10 ton per meter square, then Cn value is less than 1. So, which means that if your effective overburden pressure is more than 10 ton per meter square, then you will get the higher N value that you have to reduce by applying this overburden correction. So, that is why the Cn value is less than 1, and if your effective overburden pressure is less than 10 ton per meter square, then this is in the shallow depth. So, your measure N value is less. So, you have to apply the correction to increase that N value. So, that is why Cn value is more than 1. So, if effective overburden pressure is 10 ton per meter square, if it is less than that, then your corrected N value is more than the measure N value. If effective overburden pressure is more than 10 ton per meter square, then the corrected N value is less than the measured N value. Okay? And then we will go for the dilatancy correction. So, dilatancy correction is applied for saturated, fine sand and silt. So, first we will apply the correction due to overburden, then I will get the N dash. Now, if this N dash is greater than 15 and if this is the condition, that means saturated, fine sand and silt, then I will go for the dilatancy correction. If it is less than N dash is less than 15, then you will not go for the dilatancy correction. If it is greater than 15, then only I will go for the dilatancy correction, and this is the dilatancy correction. Finally, I will get the N double dash. This dilatancy applying the dilatancy correction also will reduce the N value. Now, why I will apply the dilatancy correction? Because this dilatancy correction, why it is 15, that is also another question. Because this dilatancy correction is generally applied for the dense soil, and generally if the soil is dense, then it will give you a higher N value. So, it is more than 15, we will treat soil as a medium dense or dense soil. So, in such case what will happen, that if we apply any impact on a dense soil, then the soil will dilate. Because of this dilatancy, the soil will expand. Okay? So, that means your volume will not decrease, it will increase, and this will happen for dense sand. It will not happen for the loose sand, it will happen for the dense sand. So, volume will increase. So, because of the volume will increase, if the soil is saturated, if the soil is dry, then also this dilatancy correction is not required. If the soil is saturated, because of this expansion of the volume, the negative pore pressure will develop. Okay? So, negative pore pressure will develop. So, because of the negative pore water pressure, what will happen? Your strength will increase. For example, we know the strength expression is sigma n dash into tan phi, because it is granular soil. So, C is 0, and this sigma n is dash is sigma n into u. That means total normal stress minus pore water pressure. Now, if the negative pore water pressure, then this will be sigma n plus u into tan phi. Phi is the friction angle. So, what will happen? Your strength will increase because of this impact, but that means you will get the higher N value. So, because of this effect, we will get the higher N value. So, to reduce that effect, and we have to reduce the N value. So, that is why we will apply the dilatancy correction. So, that means to nullify this effect, we have to reduce the N value, and that is why we will apply this dilatancy correction. So, this is the as per IS code, and then as per ASTM, American standard also, they have recommended few more corrections. So, that I will discuss in the next class. Thank you.